So today we're going to look at how we can factor using the distributive property. Now first, we need to understand that the word factor is not just a noun, it's also a verb. So it is a verb that means to pull out or find the factors of a number. So for example, if I factored 20, I could get the factor pair 4 times 5. So that's what it means to factor a number. But we're not just going to factor one number. We're going to factor two numbers, and we're going to use a common factor of those two numbers. Specifically, we're going to use the greatest common factor. So let's look at an example of what we're talking about. Or let's first look at what we're going to do, and then we'll do an example. So the first thing that I need to do is I need to find the GCF of the numbers that I've been given. The second thing I need to do is I need to write each of those numbers as the product of the greatest common factor and whatever the other factor is that I need to get the number that I was originally dealing with. And then I rewrite the problem, making sure that I have the GCF outside of the parentheses and the other factors inside of the parentheses. And then I keep the addition or subtraction sign in the parentheses. Whichever one I had is the one that I need. Now, let's look at an example of doing that. So if I wanted to factor the problem 45 plus 60, I need to start by finding the greatest common factor of 45 and 60. And the greatest common factor of 45 and 60 is 15. Once I know the greatest common factor of 45 and 16, then I want to see, well, it's 15 times, or that is the greatest common factor of 45 and 60 is 15. Then I want to see what it is that I have to multiply 15 by to get each of the numbers 45 and 60. And it's 15 times 3 that I need to get 45, and it's 15 times 4 that I need to get 60. So watch how that's all going to come together as I rewrite this problem. So I have factored out the 15. I have found that the greatest common factor of 45 and 60 is 15. So I factored the 15 outside of the parentheses, and the 3 and the 4 are inside of the parentheses, and I have a plus, or I have an addition sign, because that was what was originally between the two numbers anyway. So I could say that 45 plus 60 is also equal to the product of 15 and the sum of 3 and 4. Now, if you've done any area model work at all, what that also means is I could think of this as an area model. So in my area model, I have 45 and 60, and I want to fill out the other numbers. The number that's here needs to be as big as it possibly can be. So the biggest number it possibly can be is 15, because that's the biggest number that goes into both 45 and 60. Or in other words, it's the greatest common factor of 45 and 60. And then it's 15 times 3 that gives us 45, and 15 times 4 that gives us 60. So right here then is my problem, 15 times the sum of 3 and 4. And I have now factored 45 plus 60. Let's look at some examples. So if I want to factor 20 plus 35, again, I could think of this a couple different ways. I could think of it as an area model, where I have 20 plus 35. The biggest number I can possibly get that is a common factor of 20 and 35 is 5. And it's 5 times 4 to give me 20, and 5 times 7 to give me 35. So the best factorization of 20 plus 35 is 5 times the sum of 4 and 7. Now, if you ever use the ladder method for finding GCF, notice that if I factored 20 and 35, 5 goes into both of them, and it's going to go in 4 and 7 times. Right here is my number that goes outside, the GCF. 5 times 1 is 5, so 5 times the sum of, here are my two numbers on the inside, 4 and 7. So that's one way you could also do this, or one way you could also think of this. All right. Now, looking at another problem, 32 minus 12. I can factor subtraction problems also. It's really the exact same as factoring an addition problem, except I'm going to have a subtraction symbol inside the parentheses to match the subtraction symbol that was in my original problem. So for 32 minus 12, so the best way that I could think of this one, it's really kind of hard to do this one with an area model, is just finding the GCF of 32 and 12. And we could do that a lot of different ways. If I use the ladder method, I'm going to say maybe 2 goes into both of those, giving me 16 and 6. And then 3 goes into both of those. Oops, 3 does not go into both of those. I could say that 2 goes into both 16 and 6. 2 goes into 16 8 times, and 2 goes into 6 3 times. I am now done because I can't find any common factor of 8 and 3 except for 1. And my GCF is 2 times 2, which is 4. So 4 times the sum of 8 and 3. And it's actually going to be the difference of 8 and 3 because we originally had a subtraction, not an addition. So 8 minus 3. So I could factor this one to be 4 times the sum of, or times the difference of 8 and 3. And if I actually work that out, sometimes people don't think that this works with subtraction also, but if I actually work this out, 32 minus 12 is 20, and 8 minus 3 is 5, 4 times 5 rather, is 20. So we get the same thing either way. So that does work to factor a subtraction problem as well. Looking at a couple more examples, 72 minus 45. Again, this is a little bit hard to represent with an area model. So I would just look for the GCF of 72 and 45 and go from there. See if you can do this. Pause it for a minute while you try it, and then check and see if you're right. Okay, so for 72 minus 45, you should have gotten that the GCF is 9. And so that means 9 times 8 is what gives us 72. 9 times 5 is what gives us 45. And I'm going to put a subtraction sign in there because this one was subtraction. So 9 times the difference of 8 and 5. If you tried 36 plus 60 as well, which hopefully you did, then 36 plus 60, if you wanted to use an area model for that one, you're going to find that the biggest number that goes into both 36 and 60 is 12. 12 goes into 36 3 times. 12 goes into 60 5 times. So you can rewrite this as 12 times the sum of 3 and 5. Now, people will sometimes say, well, can you do it a different way? Can you do it as maybe you could do 6 times the sum of 6 and 10? And will this work? Well, yeah, technically you have factored that. And it is a correct factorization. It's just not the best factorization. Another factorization could be 2 times the sum of 18 and 30. Again, that is a correct factorization, but it is not the best factorization. So that brings up the question then, how do you know when you have the best factorization? Well, the way that you know is because you have the biggest number outside of the parentheses possible. In other words, you have the GCF outside of the parentheses. But that makes you, how do you know then that you do have the biggest number? Well, the best way to know that is if we go back and we look at our couple of examples we did. If you look at the ones we did for 36 plus 60, notice that in the two that I said were correct, but they weren't the best factorizations, notice, don't 6 and 10 still share a common factor? Yeah, they do. They share 2 as a common factor. 18 and 30 also share a common factor. They share 6 as a common factor. But now look up here at the one that I said was the best factorization. Notice they have 3 and 5 inside of the parentheses. The only factor that 3 and 5 share is 1. So when the two numbers on the inside have a GCF of 1, meaning they don't share any common factor except 1, that's how you know that you have the best possible factorization for the problem you're looking at. I'm going to give you just a couple more to try. Try those, and then when you're done, hit play and see if you have them correct. All right, if you have done these correctly, then you should have 5 times the sum of 9 and 7 for the first one. You should have 3 times the sum of 7 and 8 for the second one. You should have 8 times the difference of 7 and 4 for the third one, and you should have 6 times the difference of, or times the sum rather, of 6 and 7.